Welcome back to 11.2, probability of compound events. So we're going to find the compound probability. You must decide how many options you have and how many of them are favorable, just like what we did with regular probability, where we discuss what do we want to happen, and that's our top number, over the total number of things that could happen. So it says draw a diagram for the option of rolling 2 dice. What is the probability of getting a number that is prime when the dice are added together? So the first thing we're going to do is make a diagram. So I've kind of modified my tree diagram just because it was not going well the other way. So for dice number 1, I could choose the number 1, 2, 3, 4, 5, or 6, or I should say roll it. Now for my second dice, if I roll a number 1 the first time, I could again roll a 1, a 2, a 3, a 4, a 5, or a 6. And same thing with 2, 3, 4, 5, and 6. So I'm just going to copy here, make my life a little bit easier. Okay, so from the number 2, we could have 1, 2, 3, 4, 5, 6. From the number 3, we could have a 1, 2, 3, 4, 5, 6. From the number 4, we could have a 1, 2, 3, 4, 5, 6. And I'm just going to do this off to the side just so there's more room for my 5 and 6. Same thing with 5. And same thing with number 6. So we have a lot of options here. Now, the big thing to realize is this question was asking us, they want to know when a prime number appears when the dice are added together. So I need to add dice 1 and dice 2 together. So if we look at this, we're looking at all of our possible outcomes. So if I add 1 and 1, that gives me an outcome of 2. 1 plus 2 is 3. Then 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. 1 plus 6 is 7. So far we have the outcomes of 2, 3, 4, 5, 6, and 7. So since we're looking at prime numbers, I am going to just start highlighting my prime numbers so I have them. So 2 is prime, 3 is prime, 5 is prime, and 7 is prime. Okay. Then we have the probability of getting, excuse me, of getting a 2, and then what happens. So 2 plus 1 is 3, 2 plus 2 is 4, and then we're going to have 5, 6, 7, 8. They go in nice order for us. And again, I'm going to highlight my primes here. So 3, 5, and 7 are my prime numbers. Now we're going to add 3 to every number. So 1 plus 3 is 4. 3 plus 2 is 5. 3 plus 3 would be 6. And then 7, 8, 9. And again, we're going to highlight those prime numbers, which would be 5 and 7 in this one. Now if we add 4 to every number, 1 plus 4 is 5. 2 plus 4 is 6. And then we're going to have 7, 8, 9, and 10. And again, if we highlight those prime numbers, 5 and 7 are our only primes there. And if we get to 5 here, 5 plus 1 is 6, 5 plus 2 is 7, 8, 9, 10, and 11. And my only prime, or I have 2 prime numbers here, 7 and 11. And our last one, 1 plus 6 is 7. 6 plus 2 is 8. 6 plus 3 would be 9. 6 plus 4 would be 10. 6 plus 5, 11. 6 plus 6, 12. And again, highlighting those prime numbers, which would just be 7 and 11 in this case. So those are all of my outcomes when I added them together. Sorry, I changed color there, I didn't realize. So if I count this, there's 6 in each group. So that means there's a total of 36 options. Okay? Now if I count how many primes, there are 1, 2, 3, 4 in this group, 3 here, 2 here, 2, 2, and 2. So I have 2, 4, 6, 8, plus 3 would be 11, plus 4 would be 15. So we'd have 15 out of 36 are prime numbers. I feel like I added that wrong. 2, 4, 6, 8, 10, 12, 3 is 15. No, I'm good. And as any good mathematician would do, we are going to reduce our fraction. So 3 goes into 36 12 times, and 3 goes into 15 5 times. So there's a 5 out of 12 chance of this occurring. Okay? All right, so we are going to look at the next example. So in a bag there are 3 marbles, 1 red, 1 blue, and 2 greens. After choosing the first marble, you replace it and then select the second marble. Draw a diagram and find the probability of getting the same color both times. Okay, so if we sit here and try to find we have our marble 1 that we're going to draw. Now it's important that we notice the word that we replaced that marble that we picked. So we have the same chance of getting the marbles the second time as we do the first time. So marble 1, our choices are red, blue, and green. Oh, and there's 2 greens, so I actually have 2 greens for my first choice. So we have red, blue, green, green. Okay, we can shorthand that if we want. Now marble number 2, or round 2, from the red, I could choose red, blue, green, or green. Same thing here, I could choose red, blue, green, or green. Again, if I chose the green one first, I could have red, blue, green, green. And if I chose the second green one first, I could have red, blue, green, green. Now the reason I included the green twice is that'll change our probability. So it says draw a diagram and find the probability of getting the same color both times. So my first option here would be getting red, red. And then red, blue, red, green. I'll zoom in here, sorry guys. And another red, green. If I look at the second set of options, I could get a blue and then a red, a blue and a blue, a blue and a green, and another blue and a green. Here I would look at green, red first, then green, blue, then a green, green, and a green, green. And I'd have the exact same options here. I'd have a green, red, a green, blue, a green, green, and a green, green again. Now again, my probability that I wanted to find was how many have the same color both times. So I want double letters. So I have a red, red, a blue, blue, and I have 2 green, greens, and another 2 green, greens. All the rest have 2 colors involved. So all the ones I underlined, there's 1, 2, 3, 4, 5, 6 total options that I want. Out of, if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 total options. And again, as we know, we are going to simplify. So we have a 3 out of 8 chance of getting a double colored marble. I hope this helps. Try the homework. Let me know if you need